All right, let's dive right in. Today, we're putting on our detective hats and we're going to step back in time to solve one of the biggest medical mysteries of the 19th century. In the process, we'll uncover the absolutely fascinating science of epidemiology. So picture this. It's London, 1854, and the city is gripped by fear. People are dying, and they're dying fast from this horrible disease called cholera. Nobody has a clue where it's coming from. The main theory at the time? That it was a miasma, a foul vapor rising from the ground that you breathed in. But there was this one physician, a man named John Snow, who just wasn't buying it. He had a hunch the answer wasn't in the air at all. So he started collecting data, creating this map that would literally change public health forever. And what it showed was that the clues, well, they were hidden in plain sight the whole time. Now, let's be clear, the situation in London was an absolute nightmare. Cholera was terrifying. It was seemingly unstoppable. And because no one knew the cause, trying to fight it felt like, battling a ghost. And that really is the million-dollar question, right? When your enemy is invisible, when you don't even know its strategy, where do you possibly begin? It's a question that, honestly, public health officials still grapple with today when new diseases pop up. And this is where our story gets its hero. Well, not just John Snow, but the entire field that he basically pioneered. The field of the disease detectives, or as we call them now, epidemiologists.
Okay, I know what you're thinking. That sounds super academic, right? But think of it this way. Epidemiology is the detective's toolkit. It's not about looking at one sick person under a microscope. It's about zooming way out and looking at the health of an entire community to find the patterns, to find the answers.
You see, the solution to this mystery wasn't going to be found in some fancy lab. The technology just wasn't there yet. Nope, the real key was in the data, the numbers, and the patterns that started to jump out when you looked at the big picture. So get this. John Snow wasn't actually hunting for a specific germ. I mean, at the time, germ theory wasn't really a thing yet. He was thinking about the problem in a totally different way. He was looking for a source. He was looking for a pattern. And that, right there, is the heart and soul of epidemiology. It's the science of finding patterns in disease, who's getting sick, where they're getting sick, and when, all to track down the ultimate cause. And on Snow's map, the story becomes chillingly clear. He put a little black dot on the map for every single person who died from cholera. And you notice that, right? The dots aren't random. They're not spread out. They form this incredibly dense cluster right around Broad Street. And what was at the dead center of that cluster? A public water pump. By just visualizing the data, he'd found his prime suspect. He actually convinced the local officials to take the handle off the pump, and just like that, the outbreak in that area started to die down. Incredible. But, finding a link, what scientists call an association, that's one thing. Any good detective knows that's not enough. You have to prove causation. Just because two things happen together doesn't mean one actually caused the other. So how do you do that? How do you make the leap from a really strong suspicion to a rock-solid scientific conclusion? Well, epidemiologists have actually developed a kind of checklist for exactly this. Think of it like this, a detective's checklist for proving who did it. First up, temporal relation. Super simple. Did the cause happen before the effect? People had to drink the water before they got sick. Makes sense. Second, strength. How strong is the connection? That cluster of deaths was so dense, it was an incredibly strong link. Third, dose response. Does more exposure lead to a bigger effect? And finally, reversibility. If you take away the suspected cause, does the effect go away? And that was the final proof. They removed the pump handle and the cholera outbreak faded. Now, this whole checklist idea isn't just some old-timey thing for cholera. Let's fast forward and see how these exact same principles were used to crack one of the biggest medical mysteries of the 20th century, the link between smoking and lung cancer. Okay, so let's look at the numbers here because they tell a pretty shocking story. If you're a non-smoker, your baseline death rate from lung cancer is about 11 per 100,000 people. For a smoker, that jumps to 123. That is a powerful association. But here's where it gets really interesting. We see what's called an interaction effect. Exposure to asbestos on its own raises the risk, sure. But for a smoker who is also exposed to asbestos, well, the risk doesn't just add up, it multiplies. Just look at that number, 602 deaths per 100,000 people.
That's the devastating power of two risk factors coming together. It's not just 1 + 1 = 2. It's more like 1 + 1 = 10. It's a powerful demonstration of how different exposures can interact to cause disease.
So, why does all of this matter? What's the big takeaway? Well, it's that this kind of detective work, this science of patterns and causes, it has fundamentally changed our world for the better. I mean, the impact is almost too big to wrap your head around. We're talking about the complete eradication of smallpox from the planet, identifying poisons in the environment, figuring out the link between tobacco and cancer, learning how to fight HIV/AIDS, and control nutritional deficiencies. Epidemiology was on the front lines of all of it, saving countless millions of lives.
And this brings us right back to our detective's checklist, specifically that last point, reversibility. This quote really says it all. Once the epidemiological evidence was clear, public health campaigns started warning people about smoking. And what happened? Lung cancer rates started to fall. You remove the cause and you reduce the effect. Case closed.
It's just an amazing legacy, isn't it? The same fundamental logic that John Snow used with a hand-drawn map to find one bad water pump is now used on a massive global scale. It shapes our health policies, it drives prevention, and it works to protect all of us, every single day.
You know, the work of a disease detective is never really over. From chronic illnesses to the threat of new pandemics, there are always more patterns to find and more mysteries to solve. It just makes you wonder, what's the next big health mystery we're going to crack?